Hi everyone, quick video here on circle theorems. So this is going to be just for higher pupils. So if you're foundation, you don't need to worry about this at all. I'm going to quickly run through the rules and then I'm going to go through a couple of examples here, okay? So it'd be worth getting a pen and paper and writing these rules down. There's certain things you need to know. So the first one I've got here is not actually a rule, but it's worth knowing and it will help you quite a lot with different exams, with different exam questions, sorry. So the first thing to think about is that when you create two radius lines. So if I draw from the centre to the edge anywhere on this circle, if I join the 2 points together, I've just made an isosceles triangle. And by doing that, technically I can then say that these two angles would be the same. And that will help you a lot with a lot of problems if you're not sure what to do or if you get stuck. Okay, so this is not really a rule, but it will help you to solve problems. So anywhere you draw from the centre to the edge, so in this case I've drawn from the centre to the edge here, centre to the edge here, join the 2 points together, you'll create an isosceles triangle where two sides are the same. Second rule, I've drawn it in two different ways here, so a lot of you might already be aware of this one. So angle at the centre is twice the angle at the circumference. So if that was x, that'd be 2x. If it was 50, that'd be 100, etc., etc. So you need to make sure that you are using the words angle at the centre is twice the angle at the circumference. Make sure you do it that way around, but some of you might not have seen it this way before. So just be really careful here. If you've got a shape that looks like this, that is also the angle at the centre. So this angle here would be twice, so that would be 2x, the angle at the circumference there. Now do not get that one confused with this one down here in the bottom left, number 5. We'll talk about that in a minute. What you need to identify is that all 4 points here touch the edge of the circle to make that cross. It looks like a bow tie, so that's how you can remember that one. Whereas this one looks like a bow tie, but that not all 4 points are touching the edge. Okay, so that is still angle at the centre being twice the angle at the circumference. Number 3 here is probably the easiest one to spot. When a radius line, so this bit here being my radius line, meets a tangent, and this is my tangent line, the angle will be 90 degrees. And a lot of time, just for putting that right angle on or right in 90 degrees would get you a mark in an exam. So probably the easiest one to remember, when a radius meets a tangent, the angle is 90 degrees. Next one, if you therefore have two tangent lines, so you can see here I've got my two tangent lines, one there and one there. If they meet at a particular point, those two lines are actually equal in length. So if I was to do that, you'd be able to work out that they would be the same length. And if I was to then do something like this and like this, I've then created a 90 degree there, 90 degree there, and then that would be a kite. So you can use that a lot of the time to help you. But the key thing to remember is that that length there and that length there are exactly the same. So tangents that meet at a point are equal in length. Okay, really important there. So there are your first 4. Say number 1's not really a rule. So looking at 5, which we just mentioned a minute ago, I like to call this one the bow tie. And its angles in the same segment are equal. It's quite easy to spot. So you see this bow tie shape, this angle here would be the same. And then if you flip it, this angle here would be the same. Okay, so it looks like a bow tie. That's the easy way to remember that one. Next one here, so if you've got a triangle in a semicircle, basically what I mean by is if the hypotenuse here is the diameter, that will create a right angle triangle. So a triangle in a semicircle is a right angle triangle, and you can say where the hypotenuse is the diameter, just to really make sure that you know that that one is your right angle triangle. So the hypotenuse would have to be the diameter in that case. Question 7 is probably the hardest one to spot, I think. So it's the alternate segment theory. Now, what this alternate segment theory says is you need to look for a triangle. So if you've got a triangle inside your circle and you've got a tangent line, imagine that you're walking along the tangent line. So here I am, walking along that tangent line. This first angle I get to will therefore be equal to the angle that I get to when I walk up the slope. So if you imagine walking along that line, first angle you get to will be equal to the slope that you walk up. And you could also reverse that. So if I go from the other direction here and walking along my tightrope here, if I go that way, that angle there would be the same as that angle there, okay? All you need to remember is the alternate segment theory, okay? And then the last one, I think is probably quite easy to spot as well. Make sure you've got a 4-sided shape where all 4 corners touch the edge. So you've got 1, 2, 3, 4 corners touching it. This angle here and this angle here, so x and y, so x plus y has to equal 180 degrees. So the opposite angles in a cyclic quadrilateral add to 180, and then this would be the same if that was z, and that was w, z plus w would also equal 180, because obviously altogether that'd have to make 360 degrees, okay? So they're your 7, 8 rules, really. So that first one's not really a rule, but will help you a lot of the time. If you are ever stuck, I think the best thing to do is probably look at that one, see if you can create an isosceles triangle somewhere. 9 times out of 10, that will help you. Alternate segment theory is quite hard to spot as well. But if you make sure you get those down and practice the wording of them the way I've written in green there, that will really help you as we move on to some examples. Okay, so moving on to the first example here, what I suggest you do is possibly pause the video here, and then once you paused it, you can have a go and then unpause it, see what I've got going on, and see what you can do. So ABC is a tangent to the circle, so it tells you this line here. So understand the question first of all. It tells you it's a tangent to the circle. So the first thing I would then be thinking about is a 90-degree angle somewhere. If I've got a tangent line, can I make a radius line, or have I been given a radius line? So I can see there I've already got a radius line. So the first thing I'd do is I'd write a 90-degree angle there, but I'd also go 90 degrees there. So I know that that bit's also 90 degrees, okay? Now by doing that, a lot of the time that'd give you a mark, and it also says give reason. So the first thing I'm going to do is you put that on, and I'm going to say when a radius meets a tangent, when a radius meets a tangent, the angle is 90 degrees. So by doing that, what I'm then going to be able to work out is this missing part here. Okay, well if that's 20 degrees, and the whole thing's got to be 90, that's going to be 70 degrees. Okay, so, and I can show my sum, I can do 90 minus 20, and I've given my reason already there. So best way to do it is actually to just draw an arrow from your diagram. It makes it a lot easier for an examiner to see what you're doing as well. So I've already dealt with that bit. Centre 0, so we know that's the centre. OBD is 20, DEB. So the next thing you need to do is actually look at what the question is asking you to find. So DEB. Okay, so it means I'm actually going to have to draw an additional line here. Okay, so that angle there is actually what I'm being asked to find. So what I now need to start doing is thinking about what can I add on, where can I get some additional marks, where can I add additional lines that are going to help me. So there's a lot going on there. Let's just zoom in a little bit so you can see what I've done. So I've got to find this blue angle ultimately before I can do anything. So the next thing I'm going to think about is, right, can I make an isosceles triangle? So we go back to this first rule here. This is going to help you quite a lot. And actually straight away, if I do that by drawing a line down there, that line there means I've created an isosceles triangle, and then therefore that is also 20 degrees. And my reason for that is going to be base angles of an isosceles triangle are equal. Okay, so that line wasn't there, I've had to draw it on, and I can now start to think about what else I can find. Because I've now got that triangle there, I can then find this. Okay, and by doing 20 plus 20, which is 40, so I can say 20 plus 20 is 40, and I can do 180 minus 40 to get 140. So this angle here would be 140, and my reason up here would be angles in a triangle add to 180. Okay, so I'm definitely giving every reason that I've got as I go through. And then finally now, what I can actually see is I've got this arrowhead rule. So we go back up here, looking at my arrowhead rule, rule number 2, the angle at the centre is twice the angle at the circumference. So straight away, I can then work out this blue angle up here would be half that, so that'd be 70 degrees. And your reason would be angle at the centre, and the one at the centre there is the one underneath it, so that 140 is twice the angle at the circumference. Okay, so I've actually found the angle it's asking me to find. It's asking me to find DEB, and I've found that angle now there. Now there was actually a bit of a quicker way I could have done that. So that's one way, and actually by me doing that, I've then guaranteed that I know I'm right. I'm just going to rub out all of that for a second, because I'm now going to give it to you in a different reason. And if you can actually find your answer in 2 different ways, then you know you're definitely right. Okay, so let's go back to the start again. So imagine if this is what I've got. By me adding in this line here, I've now got a triangle and the tangent. So I'm actually going to just rub out for a second. I'm going to imagine that this wasn't in the question. So imagine that none of that was there. Let's go back up here, and I've got here this alternate segment theory going on, because I've got my triangle, tangent line. And remember what we said with alternate segment theory is that the line that you walk along, if you imagine walking along that tightrope, the first angle you get to will be equal to the same as that one up there. So that would be 70 degrees. And your reason will be because of the alternate segment theory. Okay, obviously a lot easier to do it that way, harder to spot. And I've added in those extra lines there that we can then use to help you. Okay, so sometimes you might have to add lines onto these circle theorem questions. Okay, moving on to the next one now. So again, same thing here. It might be worth you pausing the video and then seeing what you can work out yourself. So it tells you that O is the centre of the circle. We need to find X. X has been given to us there. We've got a tangent line, so we need to figure out exactly what it is that we are finding. Okay, you might be able to do this one yourself if you have a little look and see what you're doing. As I say, pause the video. If not, I'm going to start going through it now. So again, this goes back to up here. The first thing I can spot there is this rule. Okay, so it looks like the arrowhead. It doesn't look like the arrowhead, but it is the arrowhead rule. So straight away, we've got the angle at the centre, which is this one, will be twice the angle at the circumference. So I'm just putting that in there. So therefore, that would be 80 degrees, okay? So if I redraw this, effectively what I'm doing is I'm taking this bit here, these 2 points. If I redraw it up there like that, and there like that, then I can rub out that line and that line. That's effectively what's just happened. I've just shifted the point round, okay? So thinking about that, we've then got, again, an alternate segment theory. Now, it does say give reasons for your answer. So here, this would be angle at the centre is twice the angle at the circumference. So it's really worth you getting used to writing those words down, because then it sticks in your long-term memory. And then again, let's go back to this concept. I've got a triangle in here now. I'm walking along a tangent line, so the first angle I get to will be equal to, when I walk up the slope, the angle at the top of the slope. So this actually would also then be 40 degrees, and my reason would be the alternate segment theory. Okay, so the hardest bit about that one is that the original shape was over here like this. So it looked like this, and we had that as 40 degrees. Okay, so therefore you need to understand that if that one up there is 40 degrees, that one up there would be 80. And then from there we can start to find missing angles and work it out from there. Now let's look at another way of doing that. So let's get rid of that bit I've drawn there. Let's say we already know that one's 80. What I do know is that this and this line are the same. So that's an isosceles triangle, right? So therefore, if I've got an isosceles triangle, we know that the base angles would be equal. So I could do 180 minus 80 to get 100. And then I'd divide them by 2 to get those two angles there. So 100 divided by 2 is 50. So each one of those would be 50 degrees. And my reason would be base angles of an isosceles triangle are equal. And hopefully what you can see from here as well then is that I've got a tangent line, this purple line, and I've got this line here that comes down. That has to make 90 degrees, because when a radius meets a tangent, the angle must be 90 degrees. And if that bit there was already 50, I'd be doing 90 minus the 50 to get 40. So therefore the purple angle would be 40 degrees, because when a radius meets a tangent, the angle is 90 degrees. When a radius meets a tangent, the angle is 90 degrees. Okay, so what I've done is proved it in 2 different ways that that angle X is definitely 40 degrees. By showing it 2 different ways, that means I know I'm definitely right. Okay, so that's the second example that we're doing. Moving on to the third one, a little bit more going on here. You might have to look at a couple of different rules. So pause the video, have a go at this one as well. Right, so looking at this next example, the first thing that I can spot is this bit here. So we look at the opposite angles there of a cyclic quadrilateral. because we've got all four corners touching the edge of the circle, so the opposite angles of a cyclic quadrilateral must add to 180. Then from there, what you might be thinking is you get a little bit stuck. So my advice to you would be to add that extra line in there. If you add that extra line in, it might be able to help you somewhere to create extra rules, because by doing that, what I've now done is I've created that arrowhead. Okay, so if I look here, that's my arrowhead rule. So it might help you create an isosceles triangle, but it could also help you with that arrowhead rule, and the angle at the center is twice the angle at the circumference. So if that's 70, that's going to be your 140. So if you're ever stuck, try and add that line in somewhere, see if it can help you. The next bit I can then work out is that bit there has to be 220, and the reason for that is that angles around a point add to 360. So all of this has to make 360 degrees, but also the angle at the center is twice the angle at the circumference. So it works the opposite way around as well. So where the arrow heads that way, you've actually got the reverse this side as well. Then from there, you've got these two lines, which are a really important point. So that angle there and that angle there have to be the same, because this and this are the same. So therefore, it has to add up to 360 degrees. I then take all of this away I've already got, and then divide it by 2, because the angles in a quadrilateral add to 360. And then I've got my radius and my tangent line, which finishes it off, and it ends up giving me that answer there. Okay, quite a tricky one. As I say, first thing there is to get that in, and then if you can create a radius line somewhere, that will help you finding some more rules or different shapes and go from there. Okay, right, we've got one more to look at. So last example here, it says find the reflex angle AOB. So the key thing here is that this is actually talking about the reflex part. Now, if you think about an angle, that would be the acute. If it was this way here like this, that would be obtuse. So the reflex part is going to be the bigger part. So A, let's just figure out what it is we're trying to find first of all. So AOB, which means we're going to have to add an extra line on anyway. So let's add that extra line on. And where it's asking me for the reflex angle, I'm actually being asked to then find this bit here. Okay, so I've identified what it is I'm trying to find first of all. The reflex angle AOB is that bigger part there. If it asked you for the obtuse angle AOB, it would be the inside part there. So you might be looking at this question thinking it's a bit strange because you've got no angles. Well, actually what you need to start thinking about is what are you given? Look at this here. So what I've got is a point and two tangent lines, which means these two lines are the same length. Now, it's already told me that, but it's also told me that this extra line here is also the same. So what I've actually got here is an equilateral triangle. So in an equilateral triangle, all three angles would be the same. So that would be 60, that would be 60, and that would be 60. And my reason for that would be all angles in an equilateral triangle are equal. Okay, so that's my first bit. I wasn't given any angles, but I've actually identified one straight away there. So from there, what I can now start to do is think about any of the other rules I know. What can I find? Well, again, I've got my really obvious rule. We've got a tangent line, and this is a radius. We've got a tangent line, and this is a radius. So it could be that you can now spot what to do. So you might want to pause it and carry on from here. But if I just carry on, that angle there and that angle there will actually end up being the same. So there's my radius line, there's my tangent. So that angle has to therefore be 30 degrees, because when a radius meets a tangent, so when a radius meets a tangent, the angle is 90 degrees, okay? And what we've done is 90 minus the 60 to get 30. So that there is 30 degrees, that there is also 30 degrees. So by doing that, what I've actually also got again, and as I say, drawing that blue line on has helped us anyway, this is now an isosceles triangle. So if it's an isosceles triangle, this bit here, if that's 30 and that's 30, so we've already got the 30 plus the 30, which is 60. We've got to do 180 minus the 60, because angles in a triangle have to add up to 180, which means that angle there is 120 degrees. And the reason there was because angles in a triangle add to 180. Okay, and then hopefully now you'll be able to figure out what the last bit is that we need to do. So this final bit here, this blue bit that we're actually being asked to find, this is a bit we're trying to find. We're going to do 360 minus that 120. It's really similar to the one we just did a minute ago where we were talking about angles around a point. So that's going to give me 240 degrees, and the reason is because angles around a point, add to 360 degrees. Okay, so that one's a little bit trickier to start. It's finding that 60 degrees, and once you've got the 60 degrees, then you can start using your rules. So my tips for you based on circle theorems, if we quickly go back through this, you need to know these, you need to know the rules, you need to know the wordings, you need to be able to spot those strange ones there like that, and also the alternate segment theory can be a bit awkward to spot. My other advice is to make sure you can create 2 radius lines somewhere, and an isosceles triangle will probably help you if you ever get stuck. So make sure you know the rules, and then effectively, basically, if you get stuck, add in a radius line like we did here, look for that tangent to a radius, and it'll probably help you as well pick up marks. Okay, just go step by step, build the picture. I hope you found that useful. It's quite a complex topic to do. The best thing to do is to go back and practice some, or find some more questions and practice some of them on your own. Okay, right, I hope you found that useful. See you on the next video.